Hi students, let's have the new session, and before starting the session you can see the screen. The last section we are talking about the sequence an and all that stuff, and I explained you about the arithmetic progression also. So hope you have completed the first exercise. So let's go for the second exercise, that is arithmetic progression. Before going for the exercise we need some small introduction, the same introduction whatever we have done in 10th class, same thing, but some few properties I'm going to explain. Some interesting properties are there which I have to explain. We never discussed all these properties in 10th. Now what is arithmetic progression? Let me start again. This some examples: 2, 4, 6, 8, 10. The logic is the difference between any successive terms. If you see, if they're same, then we say it is in arithmetic progression. So even though the second term, how we'll get the second term is with the first term and the difference. You take 6, the previous term is 4, and the difference you add, then you will get the third term. So this was our simple information what you learned in 10th. In general, what we write is, if the first term is a and the difference is d, we write a comma a plus d comma a plus 2d. Third term is a plus 2d. Fourth term will be a plus 3d. And if you see, suppose you want 100th term, it will be a plus 9090, 100th term. In general, we write the last term, that is nth term. Nth term is an actually, and what is nth term is simply a plus n minus 1 into d, 1 decreasing. This is your nth term. This is your nth term. Now, this is about arithmetic progression. Let's learn some properties. Take the same simple example: 2, 4, 6, 8, 10, 12. Now the first property, a simple property, I'll tell you. You add 2 plus 12 or 4 plus 10 or 6 plus 8, it's same. The first term and the last term sum, the second term and the last before, when you add up, it is same with some fixed constant value. This is your small property, very simple property. The next thing is, suppose you add this sequence with some constant value. Let me add a constant value 3 with each term. 2 plus 3 is 5, 4 plus 3 is 7, 6 plus 3 is 9, 8 plus 3 is 11, 10 plus 3 is 13, and 12 plus 3 is 15. When you add a constant term for the sequence, still the sequence is clearly, if you observe, the difference is same. So what I mean to say is, if you take, this is sequence, if you take series, let's talk about the series. Any series you take, 2 plus 4 plus 6 plus 8 plus 10, you add some constant, like we added 3, no? So let's add 3 with each term. So it will be 5 plus 7 plus 9 plus 11 plus 13. Still it is in AP. Or you subtract some constant value 1. Now this is in AP. This is also in AP. You subtract 1 for the original series. This series will subtract 1. 2 minus 1 is 1. 4 minus 1 is 3. 6 minus 1 is 5. 8 minus 1 is 7. 10 minus 1 is 9. Still it is in AP. You look carefully. 1 plus 3 plus 5 plus 7 plus 9. The difference you see, it is same, and it is in AP. So what I want to tell you is, any series 2 plus 4 plus 6 plus 8 plus 10, we take the series, you add with a constant value or you subtract with a constant value, still it is in AP. Let's see whether it is same when you multiply it. Let's multiply with 3. Each term is multiplied by 3. 2 3s are 6, 4 3s are 12, 6 3s are 18, 8 3s are 24, 10 3s are 30. See whether it is in AP. Yes, see the difference. 6 and 12, 12 minus 6 is 6, 18 minus 12 is 6, 24 minus 18 is 6, 30 minus 24 is 6. Still it is in AP. Now take the same series again. Here only we'll take. Now instead of multiplying, we'll try to divide. Divide by 2. Divide by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. 3, you get 4, and 10 divided by 2 is 5. Still it is in AP. So by this, what I want to tell you is any series, general series A plus D, A plus 2D, this is your AP series. You add with some constant value, you subtract with some constant value, you multiply with a constant value, you divide, still it will be in AP. So is that clear? So what I want to tell you is, there are some properties which you have to know. So these are the basic properties which you have learned. These are some basic properties of AP. Any AP series, you add with a constant number, you subtract, you multiply, you divide, still it will be in AP. Keep this in mind. Keep this in mind. Then I told you the first and the last term you add, second and the last before you add, it will be the same constant value. Most important property. Very interesting problems are there based on this. Then we talk about sum to n terms. Even we have this in our 10th sum to n terms. I discussed about the nth term. Now I am discussing about the sum to n terms because second exercise is related with nth term and sum to n terms. Second exercise is completely 10th class. Little bit higher level problems we will discuss, but it's completely 10th class. So let's talk about sum to n terms. You remember the formula, I believe. We have very interesting formula. Sum to n terms, sorry. Sum to n terms formula is n by 2 into 2a plus n minus 1 into d. This is sum to n terms. N is for the number of terms. N by 2 into, can I write 2a as a plus a plus n minus 1 into d. Now what is a plus n minus 1 into d? We know that it is simply the nth term or last term. I can write it as an. In place of a plus n minus 1, since it is nth term, I can write like this. So the meaning of this is simply n by 2 into first term plus last term, assume it as an or L. So this is sum to n terms. Sum to n terms, this is one formula we have, and one more formula is this one. It depends upon problem to problem. Now the formula is there, but you should know the terminology and you should know the notations. The beautiful notations you have: SN, AN, what is A, what is N, what is D, what is L. This should be clear. L or AN, they are one and only same, nth term, last term. A is for the first term. Some will write A, some will write A1, whatever. The first term is A. N is for the number of terms. What do you mean by number of terms? Suppose you have 1, 1 plus 2 plus 3 plus 4 plus 5. How many terms we have here? 5. What is L? Also 5. Imagine we'll take 6. What is N? N is number of terms. 1, 2, 3, 4, 5, 6. What is the last term? Last term will be 6. If you take 5, let's take 5 itself. Why to take a, so 1 plus 2 plus 3 plus 4 plus 5, the number of terms are 5 and the last term is 5. You take one more like 2 plus 4 plus 6 plus 8 plus 10. What is N? N is 1, 2, 3, 4, 5. Now what is L? L or AN? Please understand the notations. What is AN? Nth term. What is L? Last term. That is 10. What is D? D is the difference. 4 minus 2. 6 minus 4. 2. Then, like I said, AN is clear, A is clear, N is clear, D is clear, and SN. SN is the sum to n terms. If you take an example of this, you want to find the sum of all this. So let's see what will be this. 2 plus 4 6, 6 plus 6 12, 12 plus 8 is 20, 20 plus 10 is 30. We know that this is 30. This 30 is nothing but sum to n terms, and we have the formula. One formula is very simple. It is n by 2 into a plus l. Very simple formula. Why I am using this? There is one more formula. You see here, there are two formulas I gave you. This is one formula, basic formula. But I'm applying only n by 2 into a plus l. Why am I applying a plus l? Because we have the first and the last term. We have first and the last term. What is first term? How many terms are there? We have that also. 1, 2, 3, 4, 5. N is 5 here. So 5 by 2 into what is first term? It is 2. And what is last term? It is 10. So the value will be 5 by 2 into 2 plus 10 is 12, and 2 goes 6 times, and 5 6 are 30. That's your answer. So it's very simple. So it depends upon the formula to formula what you are applying. So this is about the sum terms. Actually, you have the derivation also, very interesting derivation. Okay, I will give you a hint. Basically, the derivation is not so important, but better you learn. So let's write sum to n terms. What you have? A plus d plus so on, a plus n minus 1 into d. So you can put the brackets like this or like this also. Now, before doing the derivation, I will teach you a small example so that you can connect that example and you can do the derivation. Okay. See, suppose you s is equal to 1 plus 2 plus 3 plus 4 plus 5. Let's add what it is. 5 plus 4, 9, 12, 14, 15. We know it is 15. Can I write the same yes in a reverse order? 5 plus 4 plus 3 plus 2 plus 1. See, we have a commutative property under addition. So if you see, you can add 1 plus 2 or 2 plus 1, it is same. So I just reversed it. Now let's add these two. S plus S is 2S. 5 plus 1, 5 plus 1 is 6. 4 plus 2 is also 6. 6, 6 and 6. So 2S is equal to, how many 6 we have? 1, 2, 3, 4, 5. So it is 30. 6 5s are 30. So S will be 15. 30 over 2 is 15. This is a small basic example. Suppose you want to do 1 plus 2 plus 3 so on up to 100. Same logic you can apply. It's very simple. So S will be again 100 plus 99 plus blah 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 plus 1. Now you add 2S is equal to 100 plus 1 is 101. Again you'll get 101. And the last term is also 101. So 2S is equal to, how many 101s we'll have? How many 101s we have? We have 100 101s we have. Let me get the logic. 101 plus 101. How many 101s we have? We have 100 because the terms are 100. So from this you can get S value 100 into 101 by 2. I think if you simplify it, you'll get 5050. 50 50 5050, you get some of the 100 natural numbers. Same logic, you apply the same logic and try to derive. Let me tell you, S is equal to A plus D, like I wrote it now, so on, A plus N minus 1. I want you to derive yourself. Again, S is equal to, you write first, you write the last term because you are reversing. No need to write the second term and all that. I'll tell you the simple logic. Write the last term here when you reverse here A. Then you add, it will be 2S. Here you should be little bit smart. You are adding the first terms. So A and this part. So A plus A is 2A. A plus A is 2A. 2A plus N minus 1 into D. Similarly, you will get 2A plus N minus 1 into D. 2A plus... so many you will get, but how many you will get means actually you will get N. N 2A plus N minus 1 into D is 2A plus N minus 1 into D is how many you will get? N. So from that you can derive your, let me write down on the top. So 2S is equal to, you will get N into 2A plus N minus 1 into D. So S is equal to N by 2 into 2A plus N minus 1 into D. This is your formula. So based on that, I expect you to do the exercise problems. That's it for today. Bye.